talking about the areas of regular polygons. But before we do that, briefly want to just review 30, 60, 90 triangles, which is a kind of special right triangle. When you have a 30, 60, 90 triangle, the side that is opposite the 30-degree angle, if we call that x, then the other two sides are going to be proportional to it. So the hypotenuse is going to be of length 2x, and the side opposite the 60-degree angle is going to be x root 3. So if this were 1, this would be 2, and then the last side would be root 3. Or if this were 2, hypotenuse would be 4, and this side would be 2 root 3. So I'm just mentioning that because it's going to come up a bunch as we're going through this stuff today. So for equilateral triangles, all three of their angles have to be the same, right? 60, 60, 60. So if I want to find the area, what I can do is I can drop an altitude here, and that's going to bisect this angle. So I'm going to have two 30-degree angles. And now I have a 30, 60, 90 triangle. So if I want to find the area of this full triangle here, I need the length of the altitude, the height, right? So I can use the 30, 60, 90 triangle relationship to say that the height, or the length of line WZ, is going to be equal to s over 2 times root 3. Since if I call s over 2, if I drop this, cut it in half, then this length is s over 2. So that means that if I just use the proportions, this is going to be s over 2 times root 3. And then to find the full area of the triangle, I do area equals 1/2 base times height. And in this case, my base is s, and my height we just said was s over 2 root 3. And this means that the area of a equilateral triangle is going to be equal to s squared over 4 times root 3. And this is always true for an equilateral triangle. And what we want to do is we want to take this and I want to generalize it to kind of any regular polygon. So a couple of vocab terms here. The radius of a regular polygon is the line segment that you can draw from the center to a vertex. The apothem is a line segment that you can draw from the center that will bisect any of the sides. If it bisects, that means it's also going to be perpendicular as well. And the theorem here that we have is that the area of a regular polygon is half the product of the apothem and the perimeter. So the area of a regular polygon is equal to 1/2 times P times A, where P is perimeter and A is the apothem. Okay. So let's use this and try to get some areas of polygons. So first example, let's say I have a regular polygon where the perimeter is 40 and my apothem length is 5. I don't even know what polygon this is. This could be a hexagon, it could be a pentagon. I don't even need to know in order to find the area because I know that A equals 1/2 times AP. So I have 1/2, A is 5, P is 40, and I get 100. Done. Easy. This one, equilateral triangle. Here I can use my version of this equation for the equilateral triangle. So it's just going to be that the area is equal to s squared over 4 times root 3. So I know one of my side lengths is 10 because it's equilateral, all three are 10. Then I'm going to have 10 squared over 4 times root 3. And this is going to give me 25 root 3. You could get a decimal for this. You also don't really have to, unless the problem really calls for it. It's fine to leave stuff in terms of root 3 or in terms of like pies if you have a pi. Okay, so let's move to another example here. So here I have a circle inscribed inside of a triangle, and I want to find the area of the triangle. And so what we're going to do is I'm going to draw a radius, a triangle radius, not of the circle, because I know the circle radius is 6. But I'm going to draw a line from the center of the circle all the way here. And now I know that this, if the circle is inscribed in the triangle, that means that this radius is perpendicular to this side of the triangle. So if this is 90 degrees, I know each side of the, each angle of the triangle is 60 degrees. So this must be 30, right? 30 degrees, which means this is 60 degrees here. which means I have a 30, 60, 90 triangle. Okay. So if I have a 30, 60, 90 triangle, I know that the full length A, let's call the origin O. I know that AO is equal to 12 because I can use the 30, 60, 90 ratios, knowing that the radius, or the side opposite 30 degrees, is of length 6. Then the hypotenuse, which is AO, must be twice that, or length 12. And then I can get my last side, AP, because AP, according to my ratios, is going to be 6 root 3, which means my perimeter is going to be equal to 36 root 3. Because it's a 6 root 3, 6 root 3, 6 root 3. So 6 root 3, right, times 3 is 36 root 3. So now I have my perimeter. I have the length of one of my apophthegms right here, which is 6. So I can get the full area. So the area is going to be 1/2 AP, which is going to be equal to 1/2 times 6 times 36 root 3. And this gives me 108 root 3. Okay. So again, the radius of the circle in this case was the apophthegm, so we already had that, and we just had to find the perimeter. And the way to do that, right, a little sneaky, we had to find the length of this triangle and kind of go from there. AP, by the way, is I'm gonna say is this is P here. Okay. Good. So, let's see. Let's do this last one here. For this one, we're finding the area of a regular hexagon. Oh, I'm so sorry. Dang it. Here, AP, I says this is times 3. Obviously, 6 times 3 is not that. Because this bit here, right, is 6 root 3, but we need the full length of the side, right, which is 12 root 3. Sorry. So really, we do this times 2 and then times 3 to get 36 root 3. Because 6 root 3 is just this length of this little piece of the triangle here, right? So if this is 6 root 3, this full thing must be 12. So this is also 12, and this is also 12. And that's why we do 12 plus 12 plus 12 is 36 root 3. Sorry about that. Okay, so example number 4, area of a regular hexagon, AF. If I draw the line, or I don't even need to, it's already labeled as 18. So I know AF is equal to 18 because every single side in a regular polygon is going to be the same length. And then what if I do this? What if I draw a line like this? So I draw a radius and I draw an apophthegm. So I know this makes a right angle. Okay. I know that let's see. I know, here's another thing I can say. I can say that if I did this, then this is 60 degrees, right? 60. This is also 60 degrees, and this is also 60. So if I bisect this, then this angle has to be 30 degrees. And so now I'm back to a 30, 60, 90 triangle. So you see at the beginning why we did 30, 60, 90, because they pop up in almost every problem. So now I have a 30, 60, 90 triangle. And I can say that AP is going to be equal to 9, right? Just because I'm bisecting this here. This has to be congruent to this. So AP is 9, AF is 18. And then by using my 30, 60, 90 triangle, I can say that OP is 9 root 3. And so my perimeter is going to be equal to 18 times 6, which is 108. And I can then find my area, because my area is 1/2 times the apophthegm length times the perimeter. So I have 1/2 times my apophthegm length is 9 root 3. We had just calculated that. Times the perimeter, which is 108. And this gives me that my full area is equal to 486 times root 3. Okay. So that is how you find the area of a regular polygon if you're given it. Depending on what information you're given, usually you're going to want to try to draw a 30, 60, 90 triangle and go from there. But sometimes, like in these first two problems, you can just plug into an equation. If you're doing more work, then remember that your end goal is always to plug into this equation of A equals 1/2 AP. And if this is your end goal, that means what the problem is asking you to do is to find an apophthegm length and find the length of the perimeter. Because then once you have those, you can get the area. Thanks for watching.